Okay, so good morning everyone again. So this is the day two session for the sentiment analysis and keyword extraction. So you guys can hear me, so confirm. So we can start. Okay, let me share my screen with you. Okay, so today's session is going to be about sentiment analysis and keyword extraction. We have covered sentiment analysis in the previous weeks, so you guys are a little bit familiar with the term, the tools, uh, and the whole general concept. But we'll go also over it in this session, and also the keyword extraction methods. So to recap, like what is sentiment analysis? Sentiment analysis uses a natural language processing NLP to determine the emotion tone in text, classifying it as positive, negative, or neutral. So for this case, what's the importance for the app reviews? So the gauge customer satisfaction and user experience. It identifies areas for app improvement. It supports competitive analysis by comparing user sentiment. Since this week challenge, I hope like everyone read the challenge document. It's The task is like you have to scrape the data from Google Play Store and do sentiment analysis, like a keyword extraction and so on. So that's why the sentiment analysis is going to be useful for us. So what are the applications for it? Like prioritizing feature update based on like user feedback. So if what does it mean when we say prioritizing feature updates based on user feedback? For example, if a user say like this app login has an issue or it's crashing, so the development team like need to check that out and try to fix it. So based on the data and based on the sentiment, we can filter like the negative uh, comments uh, and do work on them to get a better result for our like application. So the next one, measuring brand perception, like what are people thinking about our brand? So is it good or is it bad? Do they love our application or do they hate it? Like, does it have a problem or it's like is it working perfectly? So you can also get like a brand perception off of it. So another one, enhancing customer support strategy. Like I said, you can find the pain points of your application and what are the people struggling with. So you could fix that based on their comments. So all this could happen with sentiment analysis and trying to understand your data first. So when you understand your data, you can give a solution. So this is what sentiment analysis do for us for this week. So what is keyword extraction? So basically just like it's a way to pull out the most important words people keep like repeating in the reviews. Like for example, if like everyone keeps saying user friendly, like that's a good sign, right? And if many reviews say like bug or it crash or a bad application, then we instantly know like there is gonna be like there is a problem. So this like helps us in the like the development team or anyone interested that what feature use what features what feature users like care about, so what they love and what needs to be fixing like, and it's also like helps like a marketing, because you start seeing which words customer naturally use to describe the app. So like it's a quick way to spot team and trends without reading like every single review. It's gonna be like impossible to do that. So you can't read all the comments online, so you need to use the keyword extraction. So like I say, like the importance, like highlight common phrases, user friendly complaints, like reveal frequently mentioned features or issues. So the most important application of it is like guiding the app development by focusing on user mentioned features, informing marketing strategy with user preferred terms, identifying trend for product improvement. So this is a use case of like keyword extraction. So when we come to the sentiment analysis methods, we have like four methods we could use. Uh, like the first one is lexicon based, like it uses predefined word lists with like positive and negative sentiment scores, very fast, and it requires no training data. It's simple, but like struggle with context and negation and sarcasm. So and good for a quick sentiment check and like social media monitoring. So what this means is like each word has already a score. So the model just adds them up, and it's super quick and doesn't need like any training for it. So, because it has a predefined dictionary. Like for example, it says good is positive in the predefined list, and bad as a negative, or uh, it doesn't work, like it doesn't is bad. So it will compile all the words and refer to the dictionary that is given, and it will give us a sentiment analysis. So this is lexicon based method. You guys I think worked on like text blob before. So text blob is one of the lexicon based, and like Vader, we're going to see them in the demo as well. But this is the definition of the lexicon based. So yeah, or like if someone says the app is not good, like it may focus on the word good and like uh, mislead us. For example, like the app is not good. Someone said the app is not good, so it will focus on the good word, and maybe it gives us like a positive value. So it's not that perfect, but yeah, it's a quick and it doesn't need any training. So the other one is machine learning based. Machine learning based, like train models using labeled examples, learn patterns from context and adapt to different domains, needed label dataset, and may overfit if not handled carefully, and effective for deeper customer feedback and analysis and detailed classification. So this one like actually learn from like examples. We give it an example like a sample data. Like if we train it like real reviews labeled as positive or negative, it starts to understand patterns like sarcasm or like phrases such as not good. Like it's more accurate overall than the lexicon based. But the trade-off is that it needs training data and can overfit if we're not careful. So for example, if you have 100 comments, this is just an example, but machine learning needs tons of and tons of thousands and millions of data to train. But let's just say if you have 100, you can split like 20 data for training and 80 uh, for the model to predict. Yeah, so we can create the 20 datas, manually labeling it. Like we read the data, and if we think it's positive, we put positive value. If it's negative, we say negative, and if it's a neutral, and neutral. So we give it to the model, and the model will read that and create a pattern for it, so it can create a model to predict the other 80%. So this is a machine-based sentiment analysis. For the other one is deep learning methods. Uses like neural network like LSTM and Burst for deep context understanding achieves high accuracy and handle complex language patterns, require large data set and stronger computational power, and idle for like advanced tasks like aspect-based sentiment and nonce-to-text analysis. You guys can work on the deep learning as a comparison, but you can do like a fader or text blob for this task. But I think it's specified in the challenge document. You can, if you have time, you can experiment on the deep learning methods and compare the results with the lexicon method. So generally, so if someone says the app used to be good, but like after the update it's terrible, so a deep learning model like actually understand that the overall sentiment is negative, not like positive. That's the power of like context understanding. So the other ones doesn't have a context understanding. They just depend on the words alone. So, but this deep learning and neural, since it's use a neural network, like it understand context. So it reads the overall the like sentence rather than like just individual words. So they are very accurate and like capture uh, small nuances like in language, tone, like sarcasm, phrasing, all of that. But yeah, they come in a cost. They need a large data set and like strong computational power. So that's the bad side of the deep learning. The next one is rule based, like uses handcrafted rule or pattern to classify sentiment. We give it the rule, and it's transparent, like easy to customize, and requires no training data. And it's hard to scale and may fail on unexpected language. Since it's manually giving pattern and rules, it's harder to scale and good for narrow use cases or quick early stage prototypes. So you guys are hearing me right? Okay, right. Let's continue. So this is a comparison. You can see it in table like lexicon based. It's pros like easy, fast, no training data. Like the cons, misses context, poor negation handling. The machine learning handles context and it's accurate, more accurate than the lexicon based. The cons is needed a label data and overfit risk. Overfitting means uh, it fits our like data set, only our data set. It learns the pattern so well, so it won't be good for like other data sets. It will work for our data set perfectly when we test it, but if we change the data set, it will not work. That's overfitting. We're going to see that in the future lectures, but that's the overall concept of overfitting. So another one, deep learning, state of the art, captures noses, cons like larger data, high computational cost, like rule based as a transparent and no training data and harder to scale may miss cases. So these are the four steps of the sentiment, the four types of sentiment analysis. For this project, you might do like lexicon based, and if you have time or try to experiment, you can do the deep learning and machine learning. So yeah, so the this is a comparison of like better and text flow approach. So I was mentioning in the previous like sessions, better and TextFlow. We saw what TextFlow is, what it does. It is a library based on the NLTK library, and better is good for like social media data sets. Like the social media is not formal, right? So it has emojis, slangs like sarcasm, so it understands more of that. So better library is more for social media content. If we scrape from social medias, like we need to use like better more than TextFlow, so it can understand more of the emojis, sarcasm, and so on. So as you can see here, like the score range, like compound, like minus -1 to 1, polarity score also for -1. It's the same for both of them. The threshold is like positive 0.05. If it's negative, is like 0.05, and neutral is in between. No fixed threshold user for interpretation for text blob. The design focus, it's social media and informal text, the Vader. In the text blob is general purpose and formal and informal text. It will work for the social media, but not good as like Vader. So sensitivity, high capture nuanced sentiment, lower may miss subtle sentiment for text blob. So the use case, classifying X post, the Twitter posts like app reviews. So in this project, you guys are gonna use like Vader. You can also test text blob, but see the difference. If you have time, like do the Vader, also the text blob, and see the difference. So the text blob, as we have seen already, like analyzing news articles, essays, and so on. So yeah, this is the libraries we use for these methods. The lexicon based. The first group is a lexicon based method. Text blob is the simplest, and it gives you like a quick polarity score without much setup. The Vader is a bit more advanced because like it designed specifically for social media, so it understands things like emojis, slang, even all caps and like exclamation marks, and so on. Then we have the machine learning methods here, the naive Bayes and the SVM. These models actually learn pattern from the label data, and naive Bayes uses like probability to guess. Yeah, it uses probability to guess, and effective for like like dimension text features. Then we have the deep learning models. The LSTM look at text as like a sequence, and so they understand how they meaning builds from like one word to another and transforms like birth are even stronger. Like they capture context from both directions in a sentence and usually gives the most accurate results. So they are more powerful, but also like resourcefully heavy on your computers. So next part, we are going to see about the keyword extraction methods and comparative overview. So we have four types of keyword extraction for now. The first one is a frequency based. So this just counts like which words show up the most after like removing stop words like the end. That a question or unjoined? Okay, Mariam asked, should we use TextBlob as default for this project? Yeah, I think you guys are asked to do TextBlob or Vader, but I suggest you do the Vader one. We're going to that. We're going to go deep on that after we finish the session. Let's first finish the session and we going to explain that more. But yeah, Vader is for like social media and Google Play reviews. It's more suitable because people will not write in formal ways. They might use like emojis or slangs or sarcasm even. So better to use Vader. But yeah, test it with TextBlob and Vader, and you'll see the difference, or choose the other one. So, where were we? Like the frequency based, yeah. It's fast, simple, and good for quick text overviews. Shows common themes but lacks context and meaning. May highlight frequent but unimportant words. Yeah. So the second one is TF IDF. So which is a bit like smarter. Instead of only counting words, it looks like how important a word is in one document compared to the entire dataset. So if a word is very common in one app review but rare in the others, it will spotlight it. This makes it useful for things like summarization or identifying unique topics. But again, like since it's a statistical method, it doesn't truly understand the meaning behind the words. It just works off the pattern and how often they appear. So overall, frequency is simple and fast. The AF5 is smarter, more focused, and both are like great early stage tool for like exploring themes in text. So you guys have to, I think you guys have to work on them as well on the project. The next one, I think you did that in week one project, the LA, the topic modeling. So instead of pulling out individual words, this method tries to find a group of words that frequently appeared together. This group form a topic. For example, if reviews often use words like login, password, or like even failed, so those might form a login issue topic. So it will gather them as a topic and label them a login issue. So it's really helpful when you have a lot of reviews and you want to discover like hidden themes. But there's a downside to it, is that you have to decide how many topics you want ahead of time in the project. I think you guys need to do like 3 up to 5 topics, topic of like themes. So you need to predefine it first. So the second method is a part of speech tagging, like for nouns, like in short, like post tagging. So uh, nouns usually like represent the main idea people talk about. Like in this case, it might be like interface or transaction, like speed or customer service. So this method is like very straightforward and like work great with tools like Spassy, but like the catch is not every noun is useful. So and sometimes you need like a domain knowledge to decide which noun like actually matters or which doesn't. So you need like a domain specific knowledge about that. So like overall, like topic modeling helps you like discover big themes, and like while post like tagging gives you like the key concept and objects people keep mentioning about. So here you can see the differences. The pros, like frequency based, is simple and fast, but it uses irrelevant words or it doesn't get no context. Div by div, like consider corpus text. It's the body of the consider the body of the text. The cons is statistical, like make miss the semantics. Topic modeling uncover themes, but topic number setting and hard to interpret. We have to predefine the amount of themes we want before we do the topic modeling. And the post tagging focus on meaningful words. The good part, the bad part is like may include less relevant terms and need interpretation. So uh, keyword extraction techniques, yeah, we have covered that already. So the applications are like pinpointing user pain points, crash, slow, and so on, highlighting praised features, like intuitive, like fast, it's good. So guiding app updates and marketing strategy. So the development team will take this data and work. They will have an understanding of what their application is doing, what they lack, and what they need to do for the future. So this is it, guys. Before we go to the demo, you guys can hear me, right? So let's just see some examples just to grasp and understand what they means. So As always, you have to import your packaged in libraries, your text blob, NLTK, uh, your NumPy, the pandas, and so on. So we don't need to do that again. So we need to download the Vidar lexicon. As I was telling you guys, NLTK has NLTK is the base for like for text blob and Vidar lexicon. So you need to download it first. NLTK just does download in Vidar lexicon, so it will download all the packages with the predefined words. It's a dictionary of it's a bunch of dictionary that is predefined and are in NLTK. So you have to download that first. Yeah, it just in a couple of seconds it's download everything. Then you can work on it. So you just have to do this once. Then you can work on your project. So we create like a synthetic data for data set of a bank app review. So there is a review text and the review rating 5, 2, 1, and so on. So this is a sample data. So you can run this notebook on your device and see the outcomes. So this is how it's supposed to look like: review text rating in just the number of rows. So convert start rating to sentiment label for supervised ML for later. This is what I was talking about. For if you want to, for example, like with a machine learning model instead of like the Vader or the TextFlow, you need to predefine some data first, right? So this is how you do it. For example, we said here, if rating is less than 2, return negative. If rating is 3, neutral, and else positive. So we have predefined it here. So it can it understand this data, and if you want, let me show you here what I was talking about. So this is also rule based. We give it a rule. So if the rating is less than this, give it this, and if it's less than like if it's 3, give it neutral. So it has a rule. So if we put another data in it, and if we have the Coleman rating, it just gives us positive, negative, and neutral. So this is just the basic one. Sorry, guys, 1 minute. Okay, sorry. Okay, so uh, always like don't forget to clean your text to do any sentiment analysis or yeah, like clean the data first. So here we clean the data. Just we made it lowercase for now, but you can like extend with a stop word removal. Stop word is like is the like end. They don't really help us in sentiment. It just complicate the like the data we're going to do. So try to remove stop words in your projects so you can get a clean data. For example, we just load all the review text so you can have the same format. For example, good here, as you can see, it's all small letters. So let's see the frequency-based representation. So this is code to do it, like count vectorized, stop word English. So yeah, it's used the stop word. It is predefined, so the library knows what are the stop words are. So it will remove them by its own when you specify it here. So for example, it's as you can see here, the words up is counted 3 times, option like 2 times, slow 2 times, add. So just counts the word. So we know that where we which words are like frequently mentioned on the app review. So this is just frequency based. This is a basic one. It doesn't help us a lot, but yeah, this is one way to do it. So we can visualize the frequent words. The app is more mentioned than the other ones. Option, slow, ads, bank, clean, crashing, so on. So don't forget to visualize your data to see what it's showing you and what's telling you. So the next one is TF IDF representation. Is there a background noise, guys? Am I disturbing you or? Yeah. So the TF IDF representation. First, let's see what like it's a TF means it's the term frequency and IDF means it's the inverse document frequency. TF is how often a word appear in the text, and IDF how unique the word is across all reviews. And TF IDF is just multiplication of the both. So higher value of this is more meaningful words, and lower means common or like unimportant word. So what is a good number of TF IDF is no universal scale. It's just relative because like every data set is different, so it's gonna be relative to your data. Like, but generally it's small numbers. For example, if it's greater than like 0.1, it's very important. If it's between 0.05 and 0.1, it's meaningful. And if it's less than 0.05, it's low importance. So we don't need to worry about those words that have like the value 0.05. So let's just come here and see. So the app has a value of 0.1. So it must be important since we mentioned here, if it's greater than 0.1, it's very important. So slow is also very important. And so this is how you read and understand your data. So when you work with your codes or your outputs, even if you don't understand what they means, you have like you have to interpret your data and knows what it means. You can Google them or you can interpret your outputs. So you will understand like the background working of your code. So yeah, so let's compare, for example, the TF by TF with like row frequency methods. For example, just top row by frequency, it's up, options, low, ads, bank, clean, crashing, and so on. When we do with TF, also app, there is also slow in this. So it's close, but it's better than the frequency work. But you can get pretty similar results uh, in general. So you can experiment on that. Also, another one, the LDA modeling. So you guys worked on that on week 1, but you can see it also as well. So for the topic modeling, token, clean text and split. So this tokenizes the text. Tokenization means just like separating each word and like word by word. For example, if the sentence is this is very good, so we tokenize it like this will be in different word and is different. So separating the sentence into words, that's just it. That tokenization is like yeah, literally that, nothing else. So and as I was telling you guys, you need to download the stop words. So you just automatically to understand which stop words to remove. So you don't have to predefine it. So it knows that the end is the just the stop words. So to clean the data, here we can see the example like clean text. Like for example, exceptional product, very easy to use and fast. When we tokenize it, as you can see, like exceptional product, very easy. It's different for every word. And token non-stop, when we remove the non-stop values, as you can see, exceptional product, notice that there is no two in the token non-stop. So this is after we remove the non-stop stop words. So as you can like see, there is no two here because it has been removed. For example, the app is impressive and smooth, but when we come here, there is no there is no is, there is no like end. So this is how you remove the stop words. So yeah, you create your modeling, and topic one gave us this, like app, super, everything, tab, need, away, and use. So it's different for every data set. For if the data set is different in the context and the domain is different, the team will be different. So it's not the same. This is just a demo. So, like topic two is always option, payment, service listed, and so on. So I was telling you guys, like you have to predefine the to do when you do LD, you have to predefine the topic, right? So here, since we define two, it will only give us like two topics. But if you want like three or five, you need to define it here first. So this is one of the things I was talking about. So yeah, for example, topic one is a positive app experience. Words like app, super, everything, tab, needed, and so on. So user praising the app is a positive experience. So ease of like convenience, everything, tab, easy. So this is just how like it collects same themes as the things and put in like in themes. So we gave it two themes. So topic one and topic two. So the topic two complains about feature and stability. Words like option, payment, service, limited updating, frustration. So yeah, this is how you understand your data and work on the processing of the extracting words. So yeah, the another one is passy, yeah, noun pause tagging, pause tagging. So review text, for example, like it extract the noun from it, its product. The app is impressive and smooth, like great job. So the app and the job is the nouns. So it extracts nouns. So when we come to the sentiment analysis, like the text blob and the bidder, text blob, we saw that in last week. That's here you can see, for example, like exceptional product, very easy to use and fast. It's a positive, and it gives us like subjectivity and also the polarity of it, and the bidder sentiment as well. It's the same, just more tuned to social media and informal text. So yeah, we can also visualize here, as you can see, text blob in the bidder rating, how they correlate with rating of the app review and so on. So this is it, guys, for today's session. If you have any question, please do ask. Okay, Mare.
Hi, Philemon. Good morning. I
Hi.
had a question on the LDA analysis. So I'm not familiar with it. So does it just give us like the number of topics, and then it lists the words? But are we the ones that are supposed to
I'm sorry.
categorize?
Like, can you repeat that again? Sorry.
Yeah, I had a question for the LDA for the
Okay.
topic modeling.
Okay.
So does it just give us, so we specify the number of topics and then it gives us the list of words under that topic, but how do we actually make a theme out of those? Do we have to do that interpretation ourselves, or is there a way to also allow it to like because it gives us the list of words in a topic. So it might be tough if we have a lot of words to actually group them into something that we can interpret.
Okay, so yeah, that's a great question. So you don't have to like manually like finding the theme. The topic modeling do that for you, and I think you need to specify what types of topics you need for it. But yeah, you don't need like manually do the like you don't manually specify the themes you need to do. So just I think we let me open the documents. One moment. I'm sorry, I'm trying to open the challenge documents to see what's specified. Okay, so in the challenge document, it's group related keyword and phrases into 3 to 5 overarching themes per bank. So yeah, you don't need to specify that. The LDA gives it for you. So yeah.
In the demo, can you open the demo maybe? Because
Okay.
yeah.
Okay, let me share the screen. You guys see my screen or not sharing?
It's still not showing.
Okay. Okay. And so, okay, I think I got it. Share. Okay. So can you see it now?
Yes, yes, you can see.
Okay. So LD is like unsupervised model. So it's not supervised. So it will search the words and it defines and it collects the same theme as together and it gives us theme wise. So all we need to do is just specify the number of themes we need. So it's not supervised.
Okay. When you scroll to the output of the LDA,
Okay.
it gives us like topic 1, topic 2, but it doesn't really say maybe the overall theme of each topic. So that was my question. How do we interpret these and say it's because we could have a lot of things under the topic output?
Oh, okay. For this one, yeah, we
Yeah.
just for this one we just printed here for the demo purpose, like for our topic in the model, just print out topic 1 and 2. But there's a method for it. Oh, I understand your question now. So it doesn't give us like topic 1 or topic 2. So you will it will gives you the theme name. There's a method for it. There, this is not in the demo for now, but yeah, it will gives you the name of the themes. This is just for demo purpose. So we just printed out topic 1 and topic 2.
Okay. Okay. So it will give us the overall theme, and we can
Yes,
also
yes,
see the things
yeah,
under it. Okay.
yes.
Thank you.
Okay.
Okay, one more question. For the deep learning and machine learning methods, since you say they require more data, so do we have to scrape more than the 400 That is like the minimum that we.
Yeah,
All
you
right.
can. It's just the bare minimum is 400. You can scrape more than 400 as you wish. Just like
How
for
much would
everyone. I'm sorry.
how much would they need to work the machine learning methods models for the sentiment
I mean,
analysis?
there is no like exact value for it, but like if you do modeling, it needs more data to predict and to do a sentiment analysis. But yeah, you can experiment on it. You can download everything. It's not that much. They don't even have, I think, that much of data on the application. So try to download everything, and yeah, we can see it also on the daily stand up for tomorrow, like what you find. That will be a great experience for everyone. If you can, just experiment on it and we will see it together.
All right. Okay. Thank you so much, Filimon.
Okay, thank you, Mariam. So any other question or should we end the session here? Okay, on the chat. So the so to process the data we scrape, we have to filter it by language, right? So that we do not get Amharic or other language. Yes, I was telling you guys on like yesterday's session. You need to create a function that can remove the Amharic texts so that it's only English. So since sentiment analysis do only English language for now. So yeah, you need to remove that. I didn't put that on the like the script I shared you guys. So add a function to that. Okay, when processing, like checking missing and duplicate values, we also supposed to clean the non-English. Yeah, what if it has pose language? Yeah, it will probably have pose language in the scraping since it's an Ethiopian app review. It will have an Amharic also. But for now, for this project, you should remove like Amharic text you find. So work on the English language only for this project. Did I answer your question, Galap? Okay, great. Okay. So thank you guys for attending. Uh, See you on the daily stand up like after an hour. So goodbye.